A new warning from a Canadian researcher tonight. Many of the Canadian Rockies' iconic glaciers will be gone within our lifetimes.
Canada, this land of massive proportions and uncharted wilderness, has secrets below the surface still locked away from even its native inhabitants. Beyond the stunning vista of the Rocky Mountains and the vast timberlands of British Columbia, discoveries in 2025 have revealed an entirely more brutal reality. Beneath the veil of snow and stone, Canada is in dynamic flux, transforming and displaying evidence of stirring to life in places. Join us as we look into 10 incredible recent finds that are sending shockwaves through the scientific community. From the recently found volcanic system beneath British Columbia to enigmatic river course shifts in Ontario, buried ancient structures under glacial ice, and seismicity deep within the Canadian Shield. But here's the twist. Scientists say these discoveries are only the beginning. One revelation hidden beneath British Columbia may dwarf them all. Could Canada be sitting on a ticking geological time bomb? A supervolcano may be brewing beneath British Columbia. Did Canada possess a Yellowstone of its own? Recent geologic discoveries in British Columbia render that possibility a reality. Geologists employing advanced satellite technology have detected extensive ground movement in a remote coastal mountain region. Initially attributed to tectonic stress, further investigation discovered something more sinister: magma movement deep beneath the Earth's surface. A multi-institution research program has verified multiple foreboding signs. High gas releases, including sulfur dioxide and carbon dioxide, have been observed. Persistent earthquake activity is observed at depths of 7 to 10 kilometers. Satellite imagery and drone-carried heat sensors observe sharp heat anomalies, showing the slow rise of a magma chamber. It looks like the onset of a magmatic system wanting to rise, said a volcanologist with the Geological Survey of Canada. The big questions are, what's its rate and what's its actual size? Follow-up gravity measurements record minute density variations in the crust, indicating the presence of an inflating melt zone. Temperature and anomalous isotopic signatures from nearby springs provide additional evidence for magmatic activity at depth. A long-dormant region now requires urgent hazard reassessment. Scientists suspect it to be an unknown caldera system associated with the same subduction processes that have formed Mount Garibaldi and other stratovolcanoes in the region. If the magma chamber continues to grow, it may have the potential to initiate hydrothermal explosions, lava dome growth, or, in more extreme cases, Plinian-type eruptions. Historical accounts for the location are sparse because of the site's isolation. Traditional indigenous oral histories, however, recount ground shaking, strange fogs, and thunder sounds within the area, which may be evidence of former eruptive stages. If this recently discovered chamber keeps expanding, Canada may be confronted with a geological threat rivaling the most dangerous volcanoes in the world, one which scientists now race to follow in their entirety. But just when scientists thought the magma chamber was the greatest danger, nature revealed another shocking twist, one capable of rewriting landscapes overnight. What force could reverse an entire river's flow? Yukon's rivers are reversing flow again. Canada's Arctic wilderness witnessed an abrupt climatic shift that grabbed headlines in 2016. Researchers tracking the Slims River basin noticed a strange pattern in April of 2025. The river water flow rate decreased dramatically before its flow direction was completely reversed within a matter of days. The prime reason for this phenomenon was the rapid melting of glaciers. The Cascall Glacier, a major mass of ice that provides water to the area, kept posting record amounts of melting. New subterranean tunnels under the glacier started diverting meltwater off the classic Slims River course, channeling it into the Elk River basin hundreds of kilometers distant. This alteration is much more than a temporary wonder of hydrology. It portends a fundamental change in the ecosystem. Satellite photographs and overhead photos taken on site attest to widespread drying of wetlands, and formerly dormant floodplains lower down the Elk River have been subjected to sudden reactivation. A specific impacted lake, traditionally boasting a healthy regimen of migratory birdlife, dropped more than 40% of its volume within some months. Scientists have referred to this effect as river piracy, reflecting the increasingly unpredictable behavior of climate-affected geological processes. Indigenous communities were forced to adapt in the first place. A number of First Nations towns, whose local economies are based on fishing activity, have witnessed radically altered fish migration patterns. Furthermore, a hydroelectric generating station constructed in the 1990s is now operating at just 60% capacity due to diminished water flow. Glaciologists predict that numerous other rivers across the Yukon and Northwest Territories share the same fate. Many small tributaries already show preliminary signs of being diverted. Scientists are using advanced technologies, such as LiDAR and subglacial radar, to determine the most susceptible basins to being captured by competing water systems. While events are unfolding in real time in Canada's north, we are forced to rethink river dynamics in an increasingly speeding up warm world. Mysterious seismic hums beneath the Canadian Shield. Below Canada's prehistoric geologic bedrock, researchers found an otherworldly vibration that is felt and not audible. It is something emanating from under the Canadian Shield, a 4-billion-year-old titanic accumulation of ancient rock extending over Quebec, Ontario, and Manitoba. Geophysicists found this periodic low-frequency seismic wave, which they called the Shield hum. It thumps rhythmically every 7 minutes of each 24-hour period, something unprecedented in local geologic records. At first, scientists had taken either mining work or groundwater movement as probable causes. Later research eliminated both of them. Machinery vibration certainly wasn't the cause, and no significant bodies of flowing water were in the area. Some scientists speculate this could be proof of a slow slip fault, slowly releasing pressure inside the rock, a process intermittently observed before large earthquakes. Some attribute it to a much broader source, movement in Earth's mantle pressing on the crust. Ancient cities frozen under the ice. An extraordinary finding occurred when doing a fairly unexceptional ice core drilling expedition. While scientists were drilling, archaeologists recorded the use of people just south of the permafrost line, near the 300-centimeter or 100-foot mark. There were many notable artifacts found that signified human activity, including charred wood fragments along with deposits of burnt charcoal. On the spectrum of objects, the artifacts that stood out the most were the intricately crafted tools made of bone and ivory that exemplified early human production. Using sophisticated ground-penetrating radar, researchers discovered a pattern that appears to have been intentionally created, ranging beneath the ice cover. The patterned terrain suggests there are relics of dwellings, pathways, and ceremonial earthworks indicative of what could be ancient-type dwellings or other structures. The age of the site is reaffirmed through radiocarbon tests, dating back to over 5,000 years old, potentially older than other Inuit settlements, and indicative of connections to either pre-Dorset peoples or to a new civilization that is separate from Inuit. The fact that the items have remained preserved is largely due to the uniform conditions of deep freeze that kept them in a stoppered state. British Columbia's underwater caves and the creatures within. Marine biologists have discovered a remarkable marine ecosystem off the rugged coast of Vancouver Island in the Juan de Fuca Strait. The underwater caves stretch far beneath the ocean's surface and have thermal vents running up their walls. However, what truly stands out in this ecosystem is the presence of strange microbial mats that glow with very low levels of luminescence when exposed to ultraviolet light. The location of the caves next to fault zones provides critical insight into how these caves formed. Scientists believe these geological structures formed as a direct result of underwater volcanic gas activity. However, It is the incredible biota in these caves that has captured scientists' interest. Deep in the ocean, scientists have found extremophile organisms that thrive in conditions that would be hostile to most known forms of life, some of which were unknown to science until the cave discovery. These organisms survive by consuming hydrogen sulfide and form large colonies in complete darkness. The cave ecosystems are remarkably similar to hydrothermal vent ecosystems found near mid-ocean ridges. What makes this research especially noteworthy is that it is a few kilometers from land on the coast of Canada. This proximity gives scientists unique opportunities to study these ecosystems and observe occurrences that are rarely witnessed in biology. A new fault line discovered beneath Alberta's oil sands. While researchers were conducting geological surveys in the Fort McMurray area, an extraordinary discovery was made that has the potential to change our understanding of the seismic landscape. The microseismic network, designed to monitor activity in the Athabasca oil sands, uncovered definitive evidence of a previously unknown system of strike-slip faults extending beneath parts of the Athabasca oil sands deposits. The identified fault system, referred to provisionally for the time being as the Athabasca Shear Zone, possesses several intriguing features which we will consider in detail. The first observations suggest this fault system has not been active for thousands of years, with apparent inactivity for the duration of recorded history. Yet, this fault system is now exhibiting the potential for change, with recent data showing evidence for changes in stress states on the fault plane. Although previously minor historical tremors have been considered standard background activity, this new finding requires us to revisit these minor events. The ramifications of this finding extend much further than academic curiosity and will have significant ramifications across a broad range of sectors in Western Canada. There are potential financial impacts for the energy sector in Alberta and infrastructure and environmental risks for the region that should be of immediate concern. The presence of the previously unrecognized fault zone requires a full reassessment of seismic risks for the region, particularly in areas with critical infrastructure. Subglacial lakes found beneath Canadian Arctic. In an impressive achievement of remote sensing technologies, satellite radar imaging, and gravity mapping capabilities, scientists made a remarkable discovery in 2025. They found, through their research, that they had confirmed two large subterranean water reservoirs hidden beneath Ellesmere Island's thick ice cover. These astonishingly ancient subglacial reservoirs have been sealed off from the atmosphere of Earth for around 100,000 years, among the longest intervals of confinement from the environment in recorded history. Despite the extreme cold of the surroundings, these ancient reservoirs of water remain liquid due to ongoing geothermal heat from below Earth's crust and the extraordinary pressure of the overlying ice mass. The scientific community is highly interested in the potential biological significance of these isolated aquatic ecosystems. Scientists hypothesize that these closed systems potentially harbor extremely ancient microbial organisms isolated from surface living organisms and evolved independently, potentially novel species that have evolved entirely isolated from the remainder of Earth's biosphere. This discovery makes fascinating comparisons with similar findings beneath Antarctica, not least the exceptional case of Lake Vostok. Previous work on Antarctic subglacial lakes has yielded intriguing findings, the most significant of which is the presence of anomalous bacterial communities in these remarkable environments. Canadian researchers anticipate that their recently discovered lakes will be equally rich stores of as-yet unidentified biological diversity and offer unparalleled opportunities for scientific research. As the world's scientific community breathes down its neck, waiting for developments, arrangements are already underway to make the first-ever drilling expedition in 2026. The scheduled expedition promises to provide human civilization with the very first peep at these mysterious underwater worlds, potentially unlocking secrets undisturbed for millennia. The scheduled exploration has attracted international attention, with scientists hoping to pull the veil over the ice for centuries. Eruption signs detected at Mount Edziza. Mount Edziza, a large volcano complex in northern British Columbia, has been dormant for centuries. However, new satellite imaging data, alongside observations of gas emissions and rock fracturing, suggest that pressure has built up beneath the summit caldera over time. Helium-3 concentrations suggest that magma might be moving upward, and harmonic tremors have been recorded using ground-based sensor arrays. All of these factors indicate considerable changes in the volcano's activity and perhaps point to the possibility of a recurrence of volcanic activity. As such, it requires careful observation and preparation. First Nations communities near the volcano are actively involved in an extensive emergency preparedness program. Meanwhile, volcanology teams have deployed new technology, including sophisticated drones and even more advanced seismic monitoring systems, to survey the surrounding valleys. This combination of monitoring systems will provide constant surveillance of the levels of activity of the volcano complex. Massive sinkhole appears near Manitoba's limestone belt. In July 2025, the southeastern area of Manitoba experienced a stunning geological event when a large depression suddenly appeared in the vicinity of a limestone quarry. The giant sinkhole formed was about 70 meters across and went in excess of 30 meters below the ground. As news broke, residents were quickly evacuated, and roads were blocked for days after. Drone imaging in the air provided details of an interesting geological pattern surrounding the central crater. The drone images displayed concentric rings of subsidence and vertical fractures, which indicated significant underground instability in the area. Geological experts state that the formation of the sinkhole is the complex interaction of natural and anthropogenic processes. The bedrock underlying the region is limestone, which has inherent weaknesses, being extremely susceptible to chemical dissolution by groundwater, a process scientifically termed karstification. Over long time horizons, this natural phenomenon forms networks of tunnels and voids well beneath the surface landscape. Nonetheless, the collapse in 2025 appears to have been hastened by increased pumping of groundwater for agricultural irrigation, coincident with a heatwave. The swift loss of water pressure at depth may have triggered existing voids and tunnels to collapse inwards, resulting in what we can see today as a large depression at the surface. This catastrophic event raises deep questions about the potential for what may happen in the future. Is this record-breaking collapse a sign of the growth of a developing karst collapse zone below a populated area? Hidden fault system discovered in Newfoundland. Scientists at Memorial University have made a stunning discovery of an otherwise unrecognized fault zone beneath the Avalon Peninsula. Their study utilized advanced LAR technology along with satellite tilt analysis to map a large geological structure of approximately 90 kilometers depth through urban and coastal regions. The fault line traverses residences in populated towns, ridges of forestation, and highway development, and has thus far been considered geologically stable. Earlier, small tremors had been detected in the region, which scientists had attributed to residual tectonic noise. But a new ground sensor that had been installed confirmed low-frequency seismic activity characteristic of slow fault creep, a gradual motion that accumulates stress over decades without abrupt release. By examining past records, researchers discovered clusters of tiny quakes dating back to the 1950s, pointing towards prolonged subtle activity along this fault zone. Most concerning is the orientation of the fault along the directions of tectonic stress vectors on the North Atlantic Plate boundary. This would mean that potential future motion may be dictated by regional tectonic motion. In the view of experts, this region can generate earthquakes of magnitude 5 to 6. While not catastrophic, they would be sufficient to render older buildings, roads, and utilities damaged. Provincial authorities are now implementing a detailed check of building codes and emergency response strategies in some coastal towns, particularly those constructed over or along the delineated fault corridor. Bridges and infrastructure must be strengthened to resist the upcoming shaking, engineers recommend. Local schools and hospitals may soon face seismic audits as a mandate. Alberta's ice caves reveal ancient animal DNA. A breathtaking discovery was made on a spelunking trip in Jasper National Park's ice cave complex. Archaeological remains in the form of hair samples, dental remnants, and frozen fecal deposits of Ice Age extinct animals such as woolly rhinos and short-faced bears were found. The samples were tested through radiocarbon dating tests, which show that the samples were between 20,000 and 40,000 years old. What is significant about the archaeological find is that it is in extremely good condition. The cold temperature of the caves and consistent microclimate acted as a natural cryogenic storage facility, actually preserving not just bone forms but also soft tissue in whole and even partial strands of genetic material. Cave wall markings reveal scratch marks and claw impressions, which imply that these big animals may have used these rooms for protection during harsh storms or migration seasons. Researchers at the University of Alberta are currently conducting DNA tests, sequencing mitochondrial and nuclear DNA from the specimens collected. Early results point to genetic connections with contemporary bison and Arctic fox populations. Several biotech companies now offer help in cryogenically storing the samples for future synthetic cloning research. Even without cloning potential, though, the implications are immense. An understanding of how these animals endured the glacial ages can introduce an epiphany in conservation, especially as modern species contend with more unpredictable climatic cycles. Could these specimens potentially assist scientists with either the revival of extinct animals or assist current species in dealing with the challenges posed by Earth's warming climate? Unexplained heat plume, detected under Saskatchewan. In early 2025, Canada's interior was uncovered as a surprisingly warm area through thermal satellite imaging. Researchers found a large amount of heat energy beneath the Williston Basin of Saskatchewan, covering around a 30-kilometre area. The signal was first detected when scientists at the Canadian Geothermal Institute observed ground surface temperatures were 5 to 7 degrees Celsius above the normal range at depths of 12 to 15 kilometers below the crust. This is significant in part because of how close the area is to existing energy infrastructure. The heat anomaly is located near a number of inactive oil wells, which has led to enthusiasm about developing the area as an enhanced geothermal system. Enhanced geothermal systems will create a system of artificial reservoirs in order to extract energy from the thermal energy below ground. The heat signature beneath Saskatchewan is important for two reasons. It is a potential site for American clean energy production, and it provides insight into one of the most poorly understood subsurface processes on Earth. Canada's stunning geography reveals some unexpected answers hiding under the icy surface. Recent discoveries unveiled some awe-inspiring gifts: ancient Arctic settlements, a hidden supervolcano, and the very active Canadian Shield. Share your biggest discovery in the comments below. Thank you for watching, and join us for more wondrous explorations into the unknown. Stay curious.